Welcome back to a new session of the MOOC on Information Security. Today's topic is Advanced Encryption Standard. This module explains more about Advanced Encryption Standard, its structure and the transformation used in AES. From this module, a learner can achieve the following information: history of AES, basic structure of AES, the transformation used in AES. Advanced Encryption Standard, better known as AES, is a commonly used symmetric encryption algorithm. It is mainly used for encryption and protection of electronic data. It was used as the replacement of DES or Data Encryption Standard, which we have studied in the previous session, as it is much faster and better than DES. AES consists of 3 block ciphers, and these ciphers are used to provide encryption of data. History of AES. Data encryption is one of the techniques used to ensure security in data transfer and communication. AES is a variant of the Rijndael block cipher developed by 2 Belgian cryptographers, John Damon and Vincent Richmond, who submitted a proposal to NIST during the AES selection process. In January 1997, when NIST called for the proposal for new encryption system, they put forward some important restrictions, such as the algorithm had to be unclassified, publicly disclosed, available royalty-free for global use, and symmetric block cipher algorithm for blocks of 128 bits, and it should be usable with key sizes of 128, 192 and 256 bits. There were multiple submissions, and after various selection procedures, 5 of them were selected for final round on the basis of security, cost, efficiency and ease of implementation. The winning algorithm, Rijndael, is a family of ciphers with different key and block sizes. The advanced encryption standard are developed to overcome the limitations of DES, which was published in 1977. The DES suffered the problems like small sized key and blocks. AES was selected because of its security, performance, efficiency, implementability and flexibility. In December 2001, the AES was adopted for use by the US government and became Federal Information Processing Standard 197. Basic features. The basic features of AES can be listed as: AES is not following the Feastel network as in DES. It has 128 bits of block. AES has 3 allowable key sizes such as 128, 192 or 256, and AES has variable number of rounds. Structure of AES. AES is implemented in software and hardware throughout the world to encrypt sensitive data. It is a block cipher of block size 128 bits. The Rijndael algorithm can be extended to any key length, that is a multiple of 64. Hence, the key length can be 128, 192 or 256. AES comprises of a series of linked operations, some of which involve replacing inputs by specific outputs or substitutions, and others involve stuffing bits around, that is permutations. This process involves n rounds, where n depends on the key length. For key length 128, 10 rounds are used, for 192, 12 rounds, etc. The cycle of AES consists of a substitution, 2 permutations and a keying function. The 128 bits block of AES can be considered as a 4x4 matrix called the state. For example, if the input is 16 bytes such as B0, B1, B2, etc., B15, the states can be represented as S of 00, S of 01, etc., S of 33 as given the figure. AES requirements or criteria. Now let us examine The major requirements of AES. It uses private key symmetric block cipher. With an active life of 20 to 30 years, it can be implemented in both C and Java. The criteria included general security, easy implementation in software and hardware, and flexibility in encryption or decryption, keying and other factors. AES transformation. The AES encryption processes data as 4 groups of 4 bytes or states. It has 10 or 12 or 14 rounds depending on the key length. Various states of transformation are byte substitution, shift rows, mix columns, and add round key. Finally, all operations can be combined into XOR and table lookups. Hence, it is very fast and efficient. The detailed explanations of various transformation states are as follows. Byte substitution. In this state, a simple substitution has done to each byte. It uses one table of 16 by 16 matrix of byte values called as Xbox, containing a permutation of all 256 8-bit values. Each individual byte of state is replaced by a new byte, as 4 bits of the bytes are used as row value and the rightmost 4 bits are used as column values. In this state, each of the 4 rows of the matrix is shifted to the left. Any entries that fall off are reinserted on the right side of row. Shift is carried out as follows. The first row is not shifted. Second row is shifted 1 byte position to the left. Third row is shifted 2 positions to the left. Fourth row is shifted 3 positions to the left. The result is a new matrix consisting of the same 16 bytes but shifted with respect to each other. Mix columns. Here, each column is processed separately. Each byte of a column is mapped into a new value that is a function of all 4 bytes in the column. Add round key. The 16 bytes of the matrix are now considered as 128 bits and are XORed to the 128 bits of the round key. If this is the last round, then the output is the ciphertext. Otherwise, the resulting 128 bits are interpreted as 16 bytes and we begin another similar round. AES decryption. AES decryption is not identical to encryption since steps done in reverse order. It can be defined as an equivalent inverse cipher with steps as for encryption. The process included inverses of each step with a different key schedule. The step byte substitution, shift rows, mix columns and add round key repeats till get the plain text. Characteristics of AES. AES has keys of 3 lengths which are of 128, 192 or 256 bits. It is flexible and has implementation for software and hardware. It provides high security and can prevent many attacks. It does not have any copyright, so it can be easily used globally. It consists of 10 rounds for processing for 128-bit keys. Advantages of AES. It can be implemented on both hardware and software. It provides high security to the users. It provides one of the best open source solutions for encryption. It is a very robust algorithm. And the disadvantages of AES are: it requires many rounds for encryption. It is hard to implement on software. It needs much processing at different stages. And it is difficult to implement when performance has to be considered. Now, let us have a comparison of AES and DES. A comparison of AES and DES can be carried out with the following table. In this table, we will consider the properties of AES and the corresponding properties in DES. When the date of creation is considered, DES is created in 1976 and AES in 1999. The size of the block is 64 bits for DES, whereas 128 bits for AES. DES has a key length of 56 bits, while AES has key length of 128, 192, 256 and more bits. The encryption primitives are substitution and permutation for DES and substitution, shift, bit mixing for AES. The cryptographic primitives are confusion and diffusion for both AES and DES. The number of iterations are 16 rounds of identical operations for DES, while number of rounds depends on key length like 10 for 128, 12 for 192 bits or 14 for 256 bits etc. for AES. The design of both AES and DES are open and the design rationale of DES is closed, but for AES it is open. The selection process of DES is secret, but for AES it is secret but open public comment. The source of DES is IBM enhanced by NSA, while for AES it is independent cryptographers. The security of AES is most secure when compared to DES cipher and is the de facto world standard. But for AES, DES can be broken easily as it has non-vulnerabilities. While considering the attacks, non-attacks against DES include brute force, linear cryptanalysis and differential cryptanalysis. But for AES, no non-cryptanalytical attacks against AES, but side channel attacks against AES implementations are possible. AES is the encryption standard adopted to overcome the problems in DES. The module included the history of AES, features and requirements in AES and its various transformations. The decryption stages also mentioned. The features of AES like varying key length and rounds and security made it more accessible. This session explained transformation stages in detail. The decryption process is not identical to encryption since steps done in reverse, but can define an equivalent inverse cipher with steps as for encryption. Hope you understand the AES in detail. See you next time. Bye.